Welcome. Welcome to Virtualize Active Directory the right way. Welcome to VMworld. My name is Matt Liebowitz. I'm with Dell EMC Consulting. I'm the global lead for multi-cloud infrastructure.
My name is Sander Berghouwer. I'm from the Netherlands and I'm a directory service MVP for the last 10 years.
And just before we start, let's just do a quick show of hands. How many folks in this room have already virtualized Active Directory?
That's not right.
Our work here is done.
Not everybody is showing up their hands. So guys, I know this is an after lunch session, but please pay attention. So we're going to ask you one more time. Did you virtualize your domain controllers? Show of hands. Sure. Second question, keep it up please. This is a workout. So who has virtualized all of their domain controllers?
Oh,
less hands. Our work is not done yet.
All right, great. So we're going to spend some time talking about Active Directory today. You know, we're not going to talk about the nuts and bolts of, how do I size my domain controller and things like that. That's not that interesting. I have one slide on that and it's awesome, but we're not going to spend a lot of time on it. It's also not an Active Directory class. We're not going to go deep into the nuts and bolts of how Active Directory works, except to the extent that it applies to virtualization and virtualizing those domain controllers. Now, Sander is a Microsoft MVP for directory services, so we can go as deep as we need to after the session. But we're not going to spend a lot of time on sort of the nuts and bolts. So here's kind of the subjects we're going to touch on. So let's start with kind of the why. Why do we want to virtualize Active Directory? Why are you all here? Well, virtualization is, it's mainstream. This slide says it's the new normal. It's really just the normal. I mean, there's probably not a lot of folks that are saying, this is the year I'm finally going to do it. I'm finally going to virtualize my first workload. And if they are, they're certainly not in this room. So it's mainstream, it's not black magic, and it's also fully supported. Microsoft does a really nice job of supporting their workloads in a virtual environment, and this is a great example. Fully supported. They're also interchangeable, and that makes them very virtualization friendly. Domain controllers are largely identical to each other. Now there's some exceptions on that, and we'll touch on that, primarily the read-only domain controller and the domain controller that hold what are called FSMA roles, but by and large, 99% identical. Again, it's a distributed model. It's multi-master, so there's not one master server from which everyone else has to read from, so it's fully distributed. And the I/O and the CPU resources are low. Again, I'm going to touch on that, but it's not incredibly interesting. And then physical, imagine the servers that you're buying today. I know the Dell EMC customers I work with, they're buying servers that have a terabyte of RAM in a lot of cases. And while Windows Server itself can use that much memory, a domain controller is never going to use that much. You're really wasting your money if you buy a physical server just for a domain controller. Now, let's talk a little bit about sort of best practices for, virtualizing, and kind of how, for availability. So, number one, it makes good sense. It's a distributed model. Distribute domain controllers across your environment, across multiple data centers. Distribute the FSMA roles. So there's 5 roles that are part of Active Directory. If you don't know what I'm talking about, if you manage your environment, chances are they all live on the first domain controller you deployed in your environment, because that's where they go by default. You should distribute them out so they are not all on the same server so that you don't have a single point of failure. Microsoft has a great document here. Whoops, wrong slide, wrong button. Microsoft has a great document here that explains, how the roles work and where the best places are to put the roles. So follow their guidance, it's the same. Use affinity and anti-affinity rules depending on what you're trying to do. You want to avoid kind of that all eggs in one basket scenario, so make sure your FSMA roles are separated. They don't end up on the same server. But there are some FSMA roles that are more important than others, primarily the PDC emulator. And so you might want to know where that one is. And so you might want to use affinity rules on that one so you know where that host or that virtual machine always lives. Yep. Now, P2V or not to P2V. Maybe you have a physical domain controller already and you want to virtualize it. Should you P2V it? The general answer I give, you should only P2V your domain controllers if you hate yourself. That is the best reason to do it. In reality though, the reasons you might want to do it is if you have a special configuration on the server, or maybe there's software on there that you can't get rid of. So there is a document that you can follow here, a knowledge base article, but my recommendation is don't. build a new server, promote it to a domain controller, replicate the database, transfer FSMO roles, and decommission. There's no reason to P2V. Now, there's a number of common objections to virtualizing domain controllers that we hear all the time. The number one, timekeeping in virtual machines is hard, and that's true, and we're going to touch on that more in one of the live demos that we're going to do. This matters to all virtual machines, by the way, but domain controllers are very intolerant to clock drift and time shift, and you're going to see why. So that's a common objection. Some folks say, well, this deviates from my standard build process. We say every new server has to be physical and has to look like this. From what we see and what we tell customers, virtualization improves standardization. You can have templates to make them all identical, and you can provision them much more quickly than you can a physical server. So that's not a real objection. This is why Sander asked, the one in the middle here, who has a physical domain controller still? It's been a common thought that you have to keep one physical domain controller to maintain usually the PDC emulator role for the FSMO role. You're going to see in this presentation that is not necessary. It's not true. You can easily transfer FSMO roles or seize them if one is unavailable. So it's not a good objection. The next is privilege escalation. And what this means is my vCenter admin doesn't need, or rather my Active Directory administrator doesn't need to be a vCenter admin. We don't want to, there's no reason to cross those streams. My vCenter admin doesn't need to be a domain admin. Domain admin doesn't need to be a vCenter admin. We keep those completely separate. And the last one we're also going to touch on in one of our demos is the fear of the stolen VMDK. And really what that means is you've got a rogue administrator that has access to the storage system and can just essentially take the entire VMDK and all the virtual machine disk files, and now they have a copy of your domain database. As you're going to see in one of our demos, that's not a real concern that we need to worry about. So really it comes down to confidentiality, integrity, and availability when it comes to virtualizing your domain controllers.
Yep. So these are the three pillars of every information security policy. So we are going to use the same pillars in our presentation and in our demos. So let's start with the one that's not that obvious, because of course if you spell it right, it's spelled CIA, but we are gonna start with integrity.
Shouldn't it be CYA? Go on.
All right, so we're going to start with the topic that you all find very hard. So proper timekeeping with Active Directory domain controllers when they're virtualized. And this is something that happens on every virtualization platform. But luckily, vSphere is a platform that offers you the best opportunities to remediate that. And time synchronization is really important in Active Directory, and I'm really glad to see that a lot of people are taking pictures, because this is a nice slide that sums it up real good. But in short, there's a time sync hierarchy in Active Directory. Everything points down to the primary domain controller emulator in the root forest. So that one is should have the most priority to get the time right on. It's also in recent version of Windows Server that there's only going to be time sync remediation 40 hours in the past and 40 hours in the future. So that is something that if you go beyond that time frame, it's very hard to come back from. And it's the typical back to the future problems. Yep. And Kerberos, the protocol that I hope you're all using with your Active Directory and not so much NTLM and LM, really relies on proper time. So if there's more than 5-minute time difference between a device and a domain controller, for instance, or a device and a file server, or another resource, then Kerberos will fail on that, and your service desk will be flooded with calls. Now, I've got a nice animation on that, and when I created this animation, I thought, so what should I use as the shape for a virtualization host? And everyone tells them, well, that's Dell EMC boxes. So I created 2 blue boxes. Those are the virtualization hosts, and of course there's a DC1, and I think you'll all agree with me that DC1 is the most common server name in the world. And then of course there's DC2, and we've got a couple of users using devices in that same environment. Now this is the case in the same Active Directory side. It doesn't really matter for this animation, but it does for a future one. that I'm also going to show you. So let's see what happens. There's a clock on virtualization host A that synchronizes its clock towards the clock of DC1. And on virtualization host B, you see the same thing for DC2. The virtualization host will offer this feature to any VM that runs on it. And it all works out. Then there's the time hierarchy in Active Directory, and what you'll see is that way the domain controller, through other domain controllers, throughout the domain hierarchy, will get the time right on each and every device and server in your environment. So in this case, everything is working fine. But what if the clock on virtualization host A is wrong? What if time is wrong? Well, what you'll see is that that entire time hierarchy is going to switch over to wrong time. And what you actually end up with in terms of Kerberos is that when the user on the device that has the wrong time goes to the domain controller and asks for a service ticket, for instance, for a file server or whatever, and he knocks on the door of the domain controller is going to say, you know what, you've got a time difference, so we're not going to play ball. And the user is going to think, so what happened? Your service desk is going to be flooded with calls because of just a little time difference on a clock on a virtualization host. So in the past, what you saw is that many different recommendations throughout time, and I think Microsoft is now at version 7 of their recommendation on time sync in terms of Hyper-V, is that there's a lot of things that you see happening in terms of time sync. And in vSphere, what you'll see is that even if you turn off time synchronization for any virtual machine, that virtual machine will still synchronize its clock with the virtualization host when, for instance, it reboots or the VMware tool service is restarted. So this is a very interesting slide because this slide will show you, here's someone who's going to change the clock on his virtualization host right now, right? Cool. So there's two strategies that you'll be able to use to get time correct on your domain controllers as a priority and then throughout your virtualized environment. So the left one is to make the Windows time hierarchy, the virtualization host sync, all that stuff work together. The other one is an advanced scenario where you can actually edit the VM configuration file and change the values for the topics that you see on screen to 0 where they are normally 1. And of course, with VMware vRealize Orchestrator, you can do that throughout your environment once you've tested it. Now I think we're 10 minutes on the way. I think it's time for a demo.
I think so too.
Let me, hold on.
Pay no attention.
Hold on.
Just talk amongst yourselves.
I'm done.
Okay.
All right.
All right, so we're going to do, again, a number of live demos. The first one we want to talk about is exactly the scenario that Sander described. Performing a vMotion, in this case, of a host or a virtual machine to a host with bad time, and we're going to see what happens.
Yes, so this is the virtualization host with an IP ending in 126, and as you can see, it has a different time that you and I think is the correct time. So in this demo, we will actually refer to this time as Usain Bolt time because it's a little fast. And what we're going to do is we have a couple of VMs, and let me just go to my VM view. And there's two VMs. We call them Aburo and Al-Akba, and it has for several reasons, but don't worry about that. And what you'll see is that both of these VMs are on a host with IP address 118. So they're on a host with good time. Now what we're going to do is we are going to move both Aburo and Al-Akba one by one from a virtualization host with the right time to a virtualization host on Usain Bolt time.
Yeah, so why don't we hop over to them, you'll see, here, hop over to both of those guys, and you're going to see the time is correct, so we're not fooling you. 113, close enough, and 114. So current time as of we are today. So we're going to move these virtual machines via scripts. It's a little easier for us to use scripts while we're up here. So we're going to move them from the good host to the bad host. And we're going to see what happens real time.
Yes, and so just to make sure that this is no Nigerian scam, these are the scripts that we're actually using. And it's a simple vMotion of a VM to another host. The other script that we're going to use is roughly the same, it just has a different VM name. So I'm going to switch over to PowerShell right here, and I'm going to run the first script, which is...
Cross your fingers.
Yep, this is a live demo, people. This could just go terribly wrong, but we're going to try it anyway. Of course, I have to type in a password.
In front of everybody.
Oh, okay, that's the right
let's
one.
switch back over to the vSphere console, and we'll see it's performing a vMotion. Go back to the
vSphere console.
Right? So we can see, it looks like it's already done. So you can see at the bottom here, it's actually already done, went fast. Let's take a look. In this case, the console disconnects during the vMotion, so let's refresh. Big money, no whammies. And we can see the time has changed. So we didn't do anything other than perform a vMotion, right? So anyone who has DRS enabled in fully automated mode, you're probably performing vMotions frequently. So you might not realize that just simple vMotion can change a clock. Let's go check the other one now.
Yeah, let's go vMotion the other one. So it's the same script as this one. It's slightly different. It has a slightly different name. So let's see to do that one too. And the script name already gives it away a bit. So again, we'll see the vMotion going on. We'll switch to the VM. Yeah. It's still all right. It disconnected. We reconnect. And you see...
Still good.
It's still good. Now, which VM do you guys think had the advanced time settings configured? So please put your hands up if you thought that was a logba. Really, guys? You had lunch and now did you all lose the capacity to think? So put your hands up for a logba, please. That's right. Yes, a logba was a VM that has the advanced settings configured. And if we go into the vSphere console and we look at it, because we can actually do that. Settings.
All right, while he's doing that, remember guys, this applies to all virtual machines. This is not a domain controller specific problem. It's just domain controllers are highly intolerant to time shift. And so if this was your domain controller, you'd be getting some phone calls at this point.
I forgot where it's at.
All right, let's move. We're short on time. Why don't we go ahead and move on?
Yes.
So I think you're still.
Yeah, you saw it.
No, you're still up.
I'm still up?
You're still up.
Can we switch the screen then?
Oh, you want that?
Yes, please. All right. Because let's talk about replication too. So replication is really the topology and the way that Active Directory makes sure that every domain controller has the same information. And that way, if a user knocks on the door of a domain controller, he actually gets the information that is right. Integrity is about getting the right information at the right time. So replication is really important that way. And if we look at the components of Active Directory replication, and I know this is hard, guys, and I know I'll try not to keep you, or to let you fall asleep, but there's a couple of things that I feel that you need to know. And this is really, really, really down into Active Directory. So the first thing that you have to know is that every domain controller has a GUID, the Directory Services Agent GUID, and that stuff never changes. And then there's the invocation ID. And the invocation ID is actually the one that is used in active replication. So if I have a replication partnership with another domain controller as a domain controller, and I like to think myself as a domain controller, but that's a bit of a red team approach, but that's okay. If I talk to another domain controller, I will knock on its door and say, you know what, this is my invocation ID and I'm talking to you as that invocation ID. Domain controllers don't call each other by name, host name, IP address, that stuff. Replication is all about invocation ID. You can change IP addresses and names all you want. No worries. Then of course, every domain controller has a unique serial number. And that's the number of writes into the database. Now that number doesn't have to be equal among all domain controllers. As Matt already said, all domain controllers are equal. Some are more equal than others. So a global catalog, for instance, will have a higher USN because it knows more in a multi-domain environment. And what about timestamps? Because we've already covered time and I said time is important. Well, time is really the mechanism that domain controllers use when they argue. And they say, you know what? When domain controllers argue, the rule is the last write wins. I tried to explain that to my wife, didn't really work. But it's how domain controllers know which domain controller had the last edit to an object or an attribute, and that way they'll know that, okay, we'll let that one live. Now again, let me show you, because you know what, text on slides is not that interesting, and I promised that I wouldn't talk to you asleep. So let's get back to our blue boxes, and let's talk about the domain controllers running in them, and this is really inside an Active Directory site. That's really important, because between sites, everything's different. But inside a site, what you'll see is that each domain controller has that unique serial number, and each domain controller, for each and every one of its replication partner, this one's easy because there's only one replication partner, knows about the USN of each and every other domain controller. And what you'll see is when they replicate, then the USN adds up. So in this case, on DC1, I create 12 objects. A couple of users, a couple of laptops, a couple of groups. So I create them, and what you'll see is that the USN on DC1 is going up by 12, to be exactly. I replicate them over, and what you'll see is that DC2 also has a USN that is added by 12, but it also knows about the changed USN of DC1. So each and every time a domain controller replicates, it knows the USN of a domain controller. And this is why we sometimes get into trouble with replication with domain controllers. Also, the other way around works. So you'll see that each and every time domain controllers replicate, the USNs just go up and up and up and up. And in an Active Directory world, by default, a USN does not go down. It only gets up. So a couple of best practices for Active Directory replication and convergence. So please apply the defaults unless you really know what you're doing. You can always ask me, but I'll say, you know what, apply the defaults and take care of proper networking and take care of a good Active Directory domain and site design. Because if you don't, one of the problems that you might encounter is a USN rollback. And Matt is going to tell you all about that.
We'll talk about that while Sander gets our next demo ready. USN rollback is the scenario that Sander described where the USNs are only supposed to go up. But in this case, it goes backwards. So let's do kind of a representation of what that looks like through animation here, because this one is a little bit harder to demo. So we start with two DCs, DC1 and DC2, just like before. USN is at 100. I have my invocation ID 1 and 2. They're both aware of each other and they're replicating. I create 10 users, so the USN increments from 100 to 110, replicates that over to DC02. DC02 says, I've got that transaction, I accept it. Increments, again, now it's up to 110. Everything's all good so far. Now we've introduced a virtualization into the mix, and someone has decided to take a snapshot of that domain controller. So snapshot created, okay? Create 10 more users, go from 111 to 120. Replicate that over. DC02 says, no problem, I've got that, that works. Everything's still in working order. The problem with USN rollback occurs when you decide to revert that snapshot. You essentially go back in time. Prior to reverting, I am at 120. I revert that snapshot, now I'm back at 110. From the domain controller's perspective, it doesn't know anything above 110, although the other domain controller thinks it should be at 120. So we've rolled back. So let's look what happens in that scenario. So here we are again. It thinks 110. DC2 thinks 120. So we're off. I create 10 users. I'm going to reuse 111 to 120 because I don't know any better. I'm going to replicate that over to DC02. And DC02 is going to say, hang on a second, I've seen these objects before. I've seen the USN before. I can't accept these transactions. I don't trust any transactions from DC1 anymore. Now at this point, what I wanted to do is just sort of a dramatic recreation of what's going to happen in this scenario. See, it's funny because I lost 50% of my domain controllers. So what happens is DC2 can no longer replicate to DC1. DC1 has become orphaned. In this case, it's turned to dust. So we don't want that to happen. Now that is primarily a problem with every version of Windows Server prior to Windows Server 2012. In Windows Server 2012 and above, 2016 and the upcoming 2019, there's been fixes for that. The primary way to avoid this though, just don't take snapshots. And if you take snapshots for whatever reason, delete them, don't revert them, it's best to just not take them. But if you are going to be in that scenario, in this case like backup and restore of a domain controller, if say you're using image level backup and you're backing up your domain controllers, use software that is aware of this limitation and will do the things that it needs to do. In this case, eradicate the RID pool and give it a new invocation ID so that it can start replicating again. Active Directory needs all of that in order to be successfully replicating. Now, there's some tools here. RepAdmin obviously is a built-in tool in Windows. This is a way to monitor replication and make sure that it's working. And then the last one, this is sort of a newer tool, AD replication status tool. It's more of a graphical tool just to make sure replication is working across all your domain controllers in all your sites. All right, I'm going to hand you back over to Sander for a second for one more problem with domain controllers. Here you go, sir.
Yep, I'm just trying to get ready. Why don't you get, well, why don't
Here,
you...
I'll take that one. I'll put the password in.
You put it in? All right, you know it, right?
No, but I'll figure it out. How hard
All
could it
right,
be?
cool. So what we're going to do in this second demo...
No, this is, no, you got one more. Go to the next slide.
Oh, we're not even going to do the demo yet?
Not yet.
Oh, we're going to do lingering objects. Oh, cool. My favorite. So if you ever encountered this, and if you solved it, then I would call you an AD expert. So in lingering objects, we have the same two boxes, we have the same domain controllers, we have the same invocation IDs, high watermark tables, all that stuff. And what we're going to do now is we're going to take a snapshot on DC1. And on DC1, what you'll see is that there's a user and we don't like him. So what we are going to do is we are going to delete that user. You know, he ate my tuna sandwich at lunch. And he was wondering, so why does this tuna, why is its name Sander? He didn't know, but that's okay. So he ate my tuna sandwich, so I deleted his account. An eye for an eye. And the way that Active Directory replicates deletions is that it is really hard to say that you deleted a user, but you do not know what the identity of the user was because you just deleted it. So what Active Directory does, it tombstones a user. So a grave is dug, there's a nice tombstone, you shouldn't have eaten the tuna sandwich. We put the user in it, but there's no sand over it yet. We don't bury him yet, we just dig the grave and put him in there. So the way Active Directory replicates that is by replicating over that deletion. And now we have the same grave on both domain controllers. And there's a neat little process on each and every one of your domain controllers. That's the garbage collection process. And that process runs every 12 hours. And what it does, it looks for those tombstone users. And at the end of your tombstone lifetime, or if you have strict replication every 30 days, after 30 days, you'll see that the tombstone, the garbage collection process will actually bury the object. So it's gone from the database. Well, except for this admin who thought it would be smart to actually to actually revert database to a moment in time, 31, 32, or 33 days earlier. And what happens is, their user is back. Now we can't replicate any change to that. We can say, you know what, I now delete that user on DC1 and I try to replicate the change. DC2 would say, I'm sorry, for what object exactly? So what you end up with is a user on DC1 and a user that's not on DC2. So Mr. Tuna Snatcher can probably log on, well, half of the time. This is notoriously hard to troubleshoot. So what Microsoft did is they left out loud, what they did is they created a lingering objects liquidator to assist you in doing exactly that. Removing, inventory and remove your lingering objects from your Active Directory if you have any. How cool is that? Free tools. I see a lot of people take pictures now. All right, the other one is the tombstone lifetime period is default for 60 days if you have an environment that was previously Windows Server 2003 domain controllers or earlier. But if you have an Active Directory that was first stood up with Windows Server 2003 Service Pack 1 or up, what you'll see is that it's 180 days. The recommendation is 180 days, and the other recommendation is don't disable strict replication. All right, then I think it's time.
Yeah, well, let me go through the graphical part first. I'll do a little background. I was able to log into that, so I think we just need to get demo. So like I said before, Windows Server 2008 and prior, even 2002 and prior, had this problem with USN rollback. Well, Microsoft recognized that problem, and they put in virtualization-safe features for specifically domain controllers. Now this is a special object, a special attribute that's 128-bit. It's applied directly to the virtual machine. You can see it. It's actually in the VMX file. It's called the generation ID. And this is applied through a driver inside of Windows Server. It's not has nothing to do with VMware tools. So it only matters that the VM is set specifically to either Windows Server 2012 or above. Otherwise, that attribute won't appear. And you can see it right here, VM Gen ID or Gen ID X. It's added to all servers that are Windows Server 2012 or 2016. It only matters if it's a domain controller, but all of your servers will have it. And if that attribute is tracked in the local copy of the directory or the domain database for that domain controller. It's important to understand that that is not replicated. You'll see why in future slides in our demos. Only that domain controller has that copy of that Gen ID. So that anytime that generation ID changes, that's sort of the first line of defense. And it changes when you do things like revert a snapshot or restore from backup. Things like that will say Gen ID is changing, and Windows Server 2012 will kick in and actually, or 2016, kick in and actually show, provide the safety features. Now, again, this is meant to provide safeguards in case you're reverting from a snapshot or restoring from a backup. It continues to be a member of the domain. So what happens is when it's booting up, before it's able to replicate with any other domain controller, it again evaluates that local copy. That's why it's important. Evaluates the local copy of the directory, of the Gen ID in the directory database. If it's different, that's when the safety features kick in. Now, after you, let's say, boot up the virtual machine in the event of a restore, what's going to happen is it's going to see that it's different, and the safety features will dump the local RID pool, request a new RID pool from the RID master. It's going to generate a new invocation ID on the local copy. So two things can happen. One, any changes that are on that domain controller that need to be replicated out can do so, and any changes that it missed in between when the snapshot was created and when it was reverted can come back. And so again, I want to show you just sort of a graphical representation of what this looks like. Again, I've got my DC01 and DC02 back from the living here. I've got Gen ID here. Now I've added 001, USN 101. So this is similar to what we had before. I'm going to create a snapshot. Now I'm using a Windows Server 2016 virtual machine, so I know that this is safe, so I'm going to create a snapshot. All good. I'm going to create a user. USN 101, invocation IDA, replicates over to DC02. DC02 says, that's fine, I accept this transaction. Now, I'm going to revert that snapshot. I'm going to go back. Notice up here, Gen ID has changed. So what immediately happens is that driver in the guest kicks in, and it changes the generation ID on the local copy in the directory database of that domain controller. And then the RID pools gets replaced, and a new invocation ID, as you can see here, is created. So now we're B. But I'm back to 101, and I'm going to create another user. I'm going to create user 2, and I'm going to reuse USN 101 because DC01 doesn't know any better. It's been reverted. I'm going to replicate that. DC02 is going to say, I've got that, but not only am I going to accept this transaction, I'm going to give you back the one that you missed. I'm going to give you back user 1 because I know you missed that. Now, prior to Windows Server 2012 and 2016, our server turned to dust, right? We lost our server. Again, another dramatic recreation of what happens in this environment. Right? So.
Oh, we have no audio.
We had a little song to go with it. Guess didn't work. Okay, so what we want to do now is show you what that actually looks like. So let me switch over, whoops, to our demo.
I want to try again. Hold on.
You want to try again? Oh. Are we back on that side? Yeah, try one more time, just so we can sing and dance.
Do we have audio on the laptop?
It's okay, we're running out of time anyway.
All right.
Let's switch over to our demo environment, and we're going to try to demonstrate exactly what we just did. Okay, so me, you?
You
want me to do this one?
Yeah, let's do it.
I thought I'm wearing the suit. I thought I don't have to do anything like that.
What? Oh, this is the irony.
Okay, so here we are. Go ahead.
Yeah, so what we're going to do is we have DC2, as Matt is showing you, and what we're going to do is we're going to run a script on DC2.
First we're going to say, hey, listen, we are in Las Vegas. We're going to prove that there's no current snapshots on this domain controller. All good, right? I'm good. Nothing there.
Yep.
So now what we're going to do, again, we're going to run a script and make sure we're going to generate a snapshot on here. So
to be.
Okay. Okay. Type in a password. Did I do it right? Big money? I did. All right. So snapshot is happening here. You can see it in the PowerShell window. You can also see it here. And so just by virtue of taking a snapshot, nothing has happened. Everything is still fine, right? Users are still replicating. DC, in this case, DC2 is talking to DC3 and DC1. So we're all good.
Yes. And what we're going to do after we create the snapshot is we are going to create a folder on desktop, and we're going to name it something unique. So I don't know, VMworld 2018?
Sure.
I think we can be more creative, but we're open to suggestions. And we're also going to delete some users. And I think that's a really neat use case because that's something that I might see you guys and gals do. Oh, I just deleted a couple of users. Let's revert the snapshot and we're good. Well, you might not be, and we'll show you what happens.
All right, so let's just make sure we're good here. Here's our Active Directory users and computers. Here's our VMworld OU. Refresh this. Got all our users. So first things first, create a folder on the desktop. Who knows why we're creating a folder on the desktop? See it go. See, you guys are so good. We'll just call it VMworld, whatever, words, doesn't matter. Okay, so you can see we have a bunch of users here, a bunch that start with A. We have quite a few of users that start with A. So here's what we're going to do. We're going to run another script.
And we are going to delete the users that start with an A. So that's not the equivalent of using Control-A in Active Directory users and computers, or Control-B for everything that starts with a B. Now we have a script that really looks at the usernames and says, you know what, if it's a username starting with an A, we are going to delete it. And if we refresh Active Directory users and computers, what you'll see is that after synchronization, because we've done that on DC1, it has to replicate to DC2 first. Yep, we are also showing you that replication works, just like it should.
Okay, so everyone see the users that started with A are gone. So far, so good. So now we're going to run another script to revert the snapshot. We want to go back in time. So we want to bring those A users back. Sorry, was there a question? Is the snapshot done? We got a heckler in the back? Come on. Yeah, the snapshot's done.
Yes.
Good? All right. Where was I? I have no idea. Okay, so we're going to run another script here to restore the user, or restore the snapshot, or revert the snapshot,
Revert
right?
the snapshot.
So we shouldn't be doing this if we are on anything other than Windows Server 2012 or 2016. All right,
Yes.
we lost our connection here, which is fine. We can see down here the snapshot has been reverted. So now the A users, from this domain controller's perspective, should be back. Oh, we're going to refresh here. The person who said that we're going to show the folder disappear wins a cookie because the folder is gone. And now let's refresh here. Whoops. All right, so the A users are back from this domain controller's perspective.
But what you'll see is that those changes will be replicated, and then of course the users will be gone again.
Yep, so we saw for a second they were back because this domain controller was reverted to a snapshot. But then it talked to DC2. DC2 said, here's what you missed. I'm going to give you back users, all the users starting with A.
Let me see, let's refresh. Because there's a neat event ID in the event viewer for this domain controller, and it's 1109, and let's look at the latest one. That's the one we just created, and what you'll see is that this domain controller actually tells us that there's an old invocation ID that it had, there's a new invocation ID that it now uses, that it used to promote itself to all its replication partners as a new replication partner, a brand new domain controller. That event ID 1109 is also the event ID that you'll see if you use an Active Directory aware backup and restore solution after each restore.
And then we'll do one more thing just because we're running out of time anyway, so why not? We're going to create one more user. This is just to prove that replication is working, right? The domain controller is not dead. It can actually talk to its partner and replicate. Let's go to DCO2. So all we've done is just create a user. Let's say I'll just refresh that guy, give it a second, and then just let me find him. His name is Matt, coincidentally enough.
Oh, is your brother here? Probably is, right?
Yeah. Oh, there he is. I passed him. See? No one's paying attention. There's a user called Matt somebody in here. Where did he go? There I am. Okay, so what does this prove? It proves that not only can it get the stuff that it missed from DCO2, but it shows it can rejoin. It can create new users and rejoin replication. So this is a safety feature that will save you in the event of a snapshot reversion or a restore from a backup. Good, do you want to show something?
Nope.
Okay, all right, so good, that one worked. So let's go back. Okay, who has a clicker?
Here it is.
This is me?
No, it's me.
All right, take it.
So this all sounds like black magic that we all want to have in our data center. But actually, domain controller safeguards will only save you in a small number of scenarios. So if you have a really creative storage admin, and he does stuff with snapshots outside of the hypervisor platform, domain controller safeguards will not trigger. So you will end up with a domain controller that is basically screwed. The other thing is that if you do not have the VMware tools installed, if you do not have Windows Server 2012 as the operating system, then domain controller safeguards will also not trigger. This feature uses the VM generation ID feature in each and every mainstream hypervisor these days, luckily, to give you that functionality. Windows Server 2008 R2 and earlier do not know how to work with that.
Right, and that's just an important point real quick. Let's say I install Windows Server 2016 in a virtual machine and I call it a domain controller and I try to revert a snapshot and it doesn't work. One of the reasons might be in vSphere and the attributes of that virtual machine, you didn't tell it was Windows Server 2012, so ESXi did not generate this generation ID and attach it to that VM. So it's a critical point, but it's easy to overlook. Sorry, go ahead.
Yes, yep, that's perfect addition. Yep. So now that you can use snapshots, please ask yourself, should you? Right? Because you can, doesn't mean you should. Now what if we could use that same VM generation idea in another way? What if we could use that to actually ensure Active Directory domain controller availability? Well, we can, because there's a feature called domain controller cloning since Windows Server 2012, Active Directory, and what it does, it allows you to take a source domain controller, or a reference domain controller if you like, and clone it. Not just once, not just 10 times, just like Maersk did when they were attacked by NotPetya, you can do it hundreds and hundreds of times. Even as a template, you can use DC cloning to roll out Active Directory domain controllers really fast. Now there's a couple of things that you need to be aware of. It's the same stuff that happens as DC safeguards. So the new domain controller will actually discard the RID pool that was in the reference image. It will also delete the invocation ID and request it, or create a new invocation ID to make sure it's a new replication partner. And all that stuff happens in about 5 minutes. Now unfortunately we don't have the time today to tell you or show you how it's done, but what we want to do is we want to share some considerations with you on domain controller cloning. So please always shut down the reference domain controller. You do not want a domain controller rebuilding indices or whatever. You can always just avoid that situation by shutting down the reference domain controller. Now do not clone the primary domain controller emulator or the RID pool master. They are both needed when you perform the clone operations. And if you use mass DC cloning operations and you want it to work, do not give the reference domain controller or the target domain controller specifically commands to use a specific name or a specific IPv4 address. Please leave those fields empty in the XML file that you create. And of course, if you clone a domain controller, please, please, please do not perform guest customization, because it breaks that entire safeguards feature and thus your cloning. Now there's a couple of best practices. So you will need vSphere 5.0 update 2 or up. The guest operating system must be set to Windows Server 2012 or up. If you're not cloning, there's a group that you use for cloning. It's called the Clonable Domain Controllers Group. Leave it as empty as long as possible, because as an AD admin, it's your only protection from fabric admins like vSphere admins of actually cloning your domain controllers. And of course, validate all software. Now VMware Tools is safe to clone, but there might be some software, some agent, some program, some service on your domain controller that might not be. There's a PowerShell commandlet that Microsoft gives you to check them. And everything that Microsoft doesn't know, it will be flagged for you to check. If you don't perform a DC clone correctly, the domain controller will reboot into directory services restore mode. This is the same mode a domain controller will reboot in if you restore it using an Active Directory aware backup and restore solution. So if that happens to you, you know where to search. Now there's a couple of effects on disaster recovery as well with this feature. So one of the things is that this is not a true disaster recovery scenario feature. Snapshots are not stored off-site. And if you use DNS, Active Directory integrated DNS, then you please make sure that you make at least one DNS server available at all times to perform DNS. So let's talk about some more general availability considerations. Matt, take it away.
Yeah, I'll take this one and we'll get our demo ready.
Yep.
All right, general, remember I said we're not going to spend a lot of time talking about sizing. However, I do have one slide on sizing and it's awesome. Here's that awesome slide. I know you've all been waiting for it. Sizing of the domain controller is really not a big deal. Microsoft's guidance for CPU, one CPU is good enough for 10,000 users. Anything above that, generally speaking, start with 2 and scale up. Look at the performance of the existing domain controllers and make the decision from there. But they are not heavy consumers of CPU. Similar with memory. Now, memory is an interesting one because domain controllers are not that different than any other database server. They effectively are a database server. And just like every other database server, like SQL Server, it can cache the directory database in RAM so that reads come out of RAM and they are faster. And the best way to know whether you have given the domain controller enough RAM is to use this, I keep hitting the wrong button, use this perfmon counter here, database cache hit %. What that's going to tell you is how often is it reading from this cache versus reading directly from the disk. If the hit rate is low and you haven't rebooted that domain controller in a long time, chances are it could benefit from more RAM. It doesn't mean you need it, but it could benefit by putting more of the directory database in memory and having better performance. Network, although we've been talking a lot about replication and how important it is, the reality is it doesn't consume a lot of network. So VMXNet 3 is standard best practice for virtual machines. Continue to use that. Storage, again, this is not a heavy consumer of IOPS. You don't need to put this on your tier 1 storage. What you do need to do is make sure there's enough space for the directory database plus growth, because your directory database will grow as your organization grows and more objects are created, as well as anything you have to put on that domain controller. Backup agents, antivirus, security software, all those things. Other than that, it's pretty easy to size a domain controller. That's why we're not spending a heck of a lot of time on it. Okay, here, why don't you do your DNS?
So DNS, because if we're talking about Active Directory, we need slides on DNS. We need to talk about it because DNS is Active Directory's Achilles heel. And what you'll see is that without DNS, domain controllers are not able to find other domain controllers, for instance. Clients are not going to be able to find the nearest domain controller. It's all that stuff that makes Active Directory perform well. But there's just one little thing that, well, it's not really a virtualization problem per se, but vSphere has the most amazing solution for you to avoid it. And it's called the domain controller or the DNS conundrum. And what you'll see is that if you have a domain controller, DC1 again, and it boots up, what it'll ask itself is what's my IP address? So that comes from the IP configuration and it's easy. So it has an IP address. Then it asks itself, okay, I need to find other domain controllers, so let's ask DNS. What's my DNS configured server? And it's also then.10.10.10. So this is one of the most prevailing misconfigurations of domain controllers that we see out there. This is not by far a recommended practice. So now we want to start the DNS server because I have to sync with my replication partner, at least one replication partner. But the DNS zone is Active Directory integrated. So here's a chicken egg problem. And what you see is that if we ask DNS who's DC2, then it's I don't know, I haven't started. Okay, please start. Well, I can't. You have to sync first. Yeah, but I don't know how to, because I don't know how I have to do that. So where is it? Where is DC2? I don't know. You must sync first. This goes on for about 20-25 minutes. And this is something that you want to avoid because it's another 20-25 minutes that your domain controllers are unavailable. So how do you avoid it? Well, at least do not use the REPL perform initial synchronization registry setting because that will get you in an unsupported state. You don't want to be there. What you do want to do is remove references to stale domain controllers that are not even there, domain controllers that you made snapshots of before they were running Windows Server 2012, for instance. Make offline or non-functioning domain controllers operational because if it's looking for a domain controller to do the initial sync and can't find any, yet another 20-25 minutes lost. And of course the solution that vSphere offers you is to start up or restart your domain controllers and stagger those reboots so there's always DNS servers available to perform those initial syncs on. Now let's talk about confidentiality, because we've already talked enough about integrity. Right. We've already talked about availability. Now let's talk about confidentiality.
And let's talk quickly.
Yes. So you already mentioned privilege escalation, and a vSphere admin doesn't have to be a domain admin. Domain admin doesn't have to be a vSphere admin. If you really think that today, then I really urge you to reconsider that. And let's talk about VM encryption, because we have about 5 minutes left to really talk about a neat feature that we have since vSphere 6.5 for that feature. Because if we use VM encryption, what we can do is we can have the new VTPM inside the virtual machine, and if we have the new VTPM, we can have virtualization-based security. And virtualization-based security means that all credentials can be pushed into a little micro VM that runs alongside that virtual machine, where all the credentials are stored in, and that feature is called Windows Server 2016 Credential Guard. If you use that feature, you no longer have to worry about Mimikatz-based attacks, because only the signed LSASS process will be able to gain access to the hashes that Windows Server uses in its day-to-day routines.
All right, I'm going to go very quick because we're very close to running out of time. So I'm going to skip most of the words on this slide. Essentially, VM encryption does what it sounds like. It encrypts the VMDK file as well as the VM configuration files that go with it, and makes it so that if you were to steal that VMDK and the configuration files, try to register it on another host, it's not going to work. Sorry for folks that are taking pictures here. Lots of details on how it works and around who maintains the key and who has the, how vCenter interacts with the KMS. By all means, come up to us after if you want more information or if you want the slides. What we want to do is switch over and actually show you this in action. Yep. So let's quickly go to 4, and we're going to do our demo here.
Yes, so the best way to show this to you, the best way to make you feel it, is by showing you VM encryption in action. So this is Demo Crypto 1. It's one of our VMs running on our vSphere cluster. And as you can see, right here, it has the VM configuration files encrypted. This is an encrypted VM for all intents and purposes. And what you'll see is we have a script that we're going to run. We're first going to, let me see.
So what we're going to try to do is simulate that stolen VMDK, the scenario where an administrator is going to have access to your storage. It's going to take the VMDK and all of the configuration files with it. They're going to stick it on a thumb drive or something. They're going to walk out, and then they're going to try to register it on their ESXi host at home or at a competitor or another scenario like that, and then they have access to your data. So that's what we're simulating here.
I think I mistyped.
And let's just try that one more time. It doesn't seem to like that.
Nope. Remove VM doesn't work. So unfortunately, our third demo is not working. But what we would have done, would have shown you, is that we would have turned off VMCrypt 1, unregistered it, and registered it on this evil host, if you will, outside of the VM encryption realm, and it will just give you an error, even more red PowerShell return lines saying, you know what, you can't do that. And on the ESXi host itself, it will say, you cannot start this VM, you need a key for that.
All right, so with the minute or so we have left, I just want to leave you with a couple of points. One, domain controller virtualization, 100% supported. 100% from VMware, 100% from Microsoft. So no reason not to do it. It's multi-master, it's distributed, its characteristics around I/O and CPU and memory make it an excellent candidate for virtualization. Not a heavy consumer, so it becomes easier. The other great part, the best practices and the documents that Microsoft creates for domain controllers, they apply both to physical and virtual. You use the same best practices that you would for both, for things like security and replication and DNS, availability, time synchronization, right? These are all the same whether it's physical or virtual. Now AD is natively highly available by nature of the fact that it's multi-master. So there's no one server other than those FSMO roles that are more important than any of the others, and even a FSMO role can be seized. But when you add that to vSphere HA, now you have better availability than you could easily get even if it were physical. So you get better availability. So upgrade to either Windows Server 2012, 2016, or if you're brave, the next version that'll be out soon if it's not already. You're going to get domain controller safeguards, cloning, and then vSphere 6.5 to get the VM encryption that we tried to show you, and 6.7 has support for what Sander talked about around virtualization-based security.
And credential guard,
Right.
which is the feature that you really, really want in the end.
So I just want to say thank you everyone for your time. Please fill out your surveys. Come up if you have any questions. Thank you.
Thank you.